All right, so hello and welcome. Here we are, another day. Howdy. Let's go ahead and take a deep breath. Howdy. Let's go ahead and take a audio's working. What I want to do is continue what I've been working on. I want to finish the 1,000 questions and then move on to the next thing. I wanted to also shout out to I actually wanted to mention this the other day. There's a guy on YouTube who I appreciate. I thought about making a video talking about what I appreciate about this particular person, because I think he's been helpful to me in my quest to find employment. Just give me a moment. Okay. All right. This guy apparently Cloudsy. He gave some advice about like some resume tips that were pretty good. I definitely needed to improve a couple things there. And then also he uses this, which I think is cool. And I've been using this lately too. I think this is great. And I wouldn't have known about this if I didn't see him using it. So I drew a picture the other day. I forgot that I deleted my my live stream the other day where I basically fell asleep. But yeah, so shout out to that guy. I appreciate his work. I think some of the advice in some of his videos were helpful for me, I hope. And then also I like this website. This is good. Anyway, okay, so the question we're working on today is smallest string with swaps. Yeah, is that the right? Do I have the right title? I think I have the right title. Just double check. Yeah. All right. Let's see how quickly I can get through this. You are given a string S and an array of pairs of indices in the string pairs, where pairs of I is equal to A, B, indicates two indices, your index of the string. You can swap the characters at any pair of indices in the given pairs any number of times. Return the lexicographically smallest string that S can be changed to after using the swaps. Pair of indices in the string pair, array of pairs of indices in the string pairs, where pairs A, B indicates two indices, your index of the string. Swap the characters at any pair of indices in the given pairs any number of times. Okay, so basically I can take these pairs and because I can do any number of swaps, there's sort of a transitive thing that happens where if I can swap A and B and swap B and C, that implies that I can swap A with C, right? Which means that I can sort those in any order. So basically I can take all of these pairs, these indices, and write them into a, I think this is kind of a straightforward answer to this one. So it's kind of a sorting question. You could take all of the indices present in all of the pairs as like a set, probably use a Boolean vector, I think. And then you can sort those indices by their characters lexicographically, by the characters that are present at those indices. And then you can rewrite the string where the create a new string that I return. I may be able to do this using, I don't know if I can do this in place on the string. Maybe I can. Think about that for a minute. No, I mean, yeah, the easiest way is just reference back the original string's position. So I'll try to explain it. So it's like I can take a. This is probably the easiest way to do it. There may be a way to do this that's in place, like saves a little bit of memory, but I don't think I need to do that. It's probably fine. Bool indices n. Fill this with false values. We're going to say for each v in pairs, set indices of v of 0 equal to true, indices of v of 1 to true, and then I'm going to say vector of indices as bool. And then I'm going to say indices.reserve. And then for each I is 0, I is less than n, plus plus I, if indices as bool, then push back that index. I mean, I could do this inside here too. Actually, that might be better. Something like this. Yeah, I don't actually need to do it this way. So the idea is that I collect the indices that are relevant to the pair, and then I just sort those indices with a custom comparator. And that custom comparator is going to take two indices, A and B, and return S of A is less than S of B, right? Sort them lexicographically based off of, sort those indices lexicographically. And then I'm going to say result. And I'm going to say for each index I, say if indices as bool of I result plus equals S of I, or it's going to be indices. Oh no. Actually, no. Say maybe easier is do it this way. J is less than indices.size, and indices of J is equal to I, then result plus equals S of J, indices of I, indices of J. Something like this. It's a little bit difficult to explain, to describe. Not that hard to describe. DCA, BACD. Okay, so I get 0, 1, 2, 3. And those are the pairs. Oh no. So I think I'm doing this wrong anyway. DCAB 0, 1, 2, 3 would be all of the indices. I think I did this wrong anyway. No, I can't do it the way that I'm thinking here. This actually is incorrect anyway. No. I can only perform this sorting thing that I've described if all of the only across pairs that are connected to each other. The pairs that are not connected, I can't actually do it this way. That's awkward. Interesting. Maybe I should use a disjoint set data structure in order to gather these pairs into subsequences, pairs of indices into subsequences of indices that can be sorted. Yeah, that's actually what I should do. Same idea that I have here, but just a little bit different. Can then just dump all of those indices into an index array. Excuse me, and then oh, this should be incremented. Yeah, I was gonna say I don't think this is right the way this is operating. It should be ABCD actually. This code's not working correctly. This needs to be modified a little bit, but this actually is not quite correct. If this particular index is equal to I, instead of using S of I, we should use indices of J of J. When I sort DCAB, I should get 0, 0, 1, 2 should come first. Why did I get DCAB? What is going on? What? I'm missing something important here. Shouldn't these indices just be, I mean, I think I could still use the same idea. It's just not quite what I've coded here. 2, 0, 1, 2. Yeah, 2, 0, 1, 2, 3. Yeah, this is right. Okay. So okay. I know what to do. No. This is wrong. It's going to be index as bool of of I. Then I'm going to write indices of J and increment J. I think that's what it is. There we go. Okay, that's right. It's not right, but it's what I was supposed to be doing. Which actually I don't need this anymore. I need that. Right. So I'm going to write the next value in that index sequence to that spot if it's part of the sequence. That's, yeah. I didn't really. I was having a hard time articulating that. I guess I didn't really fully grasp it when I was trying to type it. I kind of understood it in my mind, but didn't really have it fully articulated. Yeah, and so you can use a disjoint set data structure here to make this a little bit easier. The way this is going to work is struct DSD. I'll try to explain how this works. So this is not too bad. Int ID is -1. Yeah, -1. Parent and size. And then we've got find and find merge. Find merge. Start with an array of DSD of size n. Initialize. Could fill this. With empty DSD values, and then each of those I can modify them. X is array of I, x.id is I, x.parent is I, and x.size is 1, right? We're going to take constant, or not constant, int index, and I'm going to say int p is going to be array of index.p, and gp is going to be array of p. .p. I tend to forget which one comes first. I think this is fine. Have a while loop while p is not equal to index. Return p. Do a half compression, it's called. So I'm going to update. Eventually, I'm going to update index to p, p to gp, and gp to its parent. And I'm also in the process of that, I'm going to set the array of indexes parent to point no longer to the array index parent, but to its grandparent, which is going to be the array index of the parent's parent, or just GP. Yeah. So that'll compress, half compress, point to the, instead of pointing to the parent, point to the grandparent, and then iterate again over these variables. Yeah, that's fine. So that's find. And then find merge has two integers a and b, constant a, constant b, and we're going to say x and y. X find a, y is find b. If x and y are already equal to each other, they're already merged, then we can return. If array of a is ID, I don't know, size is less than array of b size. Really x and y it should be. If it's greater, then we swap, because I want x and y to be pointing to, and I could use actual pointers to optimize this a little bit, but I'm not going to. So if these values, I want to use the smaller one, I want to merge the smaller one into the larger one. So I can now do DSD, alpha and beta. And this is going to be array of x, array of y. Yeah, you could use pointers to make this a little more efficient, but I don't think it's really worth the extra time. And then we're going to say alpha, which is smaller, is going to be written into beta. So alpha's parent is going to become beta ID. And alpha's size, beta size, is going to be equal to the alpha size plus the beta size. Okay. And then I think that's it. It's actually really straightforward. Just update the parent, merge the smaller into the larger, the parent, and then update the sizes. And I think that's all you need. Just find merge. Yeah. Don't think there's anything else to it. So that's a DSD implementation. Quick DSD implementation. And now for each pair, what I can do is, excuse me, it's no longer going to be indices. It's going to be indices arrays. Yeah, I really want a vector of vectors. Yeah, this is a bit confusing. I gotta think about this. Let me think here. Forgive me, I'm trying to. So this can be useful to connect the pairs together to merge. Indices based off of the pairs. That's fine. But then the question is, first things first, I want to take each of those groups and sort their indices. I also want to keep track of which indices specifically which indices were relevant here, like which indices were swapped around, sorted. This took me a lot longer than I thought it would. It's kind of long, kind of a long approach. Yeah, I mean, I could. This is kind of a confusing thing, huh? There's kind of a weird thing going on here with translations where I've got sure, I've got these groups of indices, or these sets of indices, we'll say, and then I could sort those sets, each of them based off of lexicographically with respect to what each index, which character the index represents in the original string. That's fine, and it's not too hard to do it this way. Like I could just create a vector of vectors and then walk through each of these vectors and each character and use the ID of the disjoint set to assign to a particular vector, basically using that ID as a key, and then just assign those indices in order and then sort each of those vectors individually as mentioned. So that's the order they have with respect to each other. The question then is, maybe I should create a pair, or maybe when I sort those vectors, I should actually write to my new array directly. That's kind of what I'm wondering. Maybe I can get the characters for those indices and sort the characters and then write to those indices that character string. I like that. That's a good way to do it. I like that a lot. That works. That works. Let's do it that way. Okay. I have an idea. Let's do result is going to be a copy of S, and then I'm going to have indices, index vectors, or arrays, indices arrays, just index arrays of size n. Actually, it could be an array of vectors, that's fine. And fill that. Okay. And now for each pair, I'm going to, I don't need this indices as bool anymore. I don't need any of these, actually, either of these. Just use the DSD. And I'm going to take each of these values and find merge A and B. Right, find a merge A and B. And then I'm going to walk through each of these vectors. I is less than n, increment I, const auto v is index arrays of I. And what I can do is say string current, walk through each const int index in index arrays, and set current plus equals s of index, then sort that, right? Sort current string, maybe I should just say, yeah, current's fine. And then maybe current s is better, just to note that it's a string. And then write back for each const int index of index arrays. Maybe do it this way. Int j and k. v.size. That should be v. And I think it's just, yeah, I think it's fine. Do it that way. Plus j and plus k. Actually, do I need both? Maybe I don't need K at all. No, I don't need K at all. No. So we'll have result of V of J is going to be current S of J. Yeah. Translation that happens there. So I create this string. So So I create this string of characters based off of the indices in that array. Oh, there's one more detail here. I've got to do for each. Int I is 0, I is less than n, increment I. Index arrays of I dot pushback. It's actually going to be find I. That's going to get push I in there. Yeah. So we're going to use the parent index as the ID, and then push all the indices that have that parent into that particular vector. So for each of those vectors, I'm going to create a string. I'm going to build the string based off of the indices in that array, and build that string, then sort that string lexicographically, and then write that string back into my result by using each index is going to get that match one-to-one the index with the character in that current string. So the first character of this current string will be written to that first index in the vector, and then the second character, the second index, and so on. And this is all going to be written to the result, and the result was just a copy of S. So everything that was untouched by the pairs is just left as it is, untouched. So I think this is what I want. A little more sophisticated approach. Yeah, there we go. Okay, looks good. I don't know about testing. I could do testing, but I kind of prefer not to. It's got a lot of submissions, actually. It's pretty high acceptance rate, submission rate. This should be basically linear time in the pairs, and the roughly linear, not exactly, but approximately linear in the pairs, and string length. And I think it's correct. There could be no pairs. Excuse me. There's always at least one letter in the string. I don't know if there's any. N is never 0, right? So that's important. Yeah, because I'm using these arrays, and it's 0. I could run into issues. I think I could submit this. I think it's fine. There could be no pairs at all, in which case this should work out okay. Let's see how this goes. This might be okay. Okay, could be wrong. Oh, got it. Sweet, nice. So the reason I suggest this could be wrong is sometimes I make mistakes on my disjoint set data structure. So I'll submit this 4 more times, and then I think what I'll look to do is, pretty good, 97%. I like that. 1, 2, 3, 4, 5, 6. Submit it a few more times, and then what I'm going to look to do is go for another question. I think it's gonna be the plan. Yeah, how am I doing here? 1, 2, 3, 4, 5. Let's do one more. I'm gonna go for, I think what I'll do is if you like this video, give it a like and subscribe for more. And I'll go ahead and stop the stream and find another question and start the stream again on a new question. So yeah, hail victory.